My name is Andriy Kot, and I'll talk about pretty common sense things. I'd be surprised if you didn't hear about this at some point. Maybe you didn't pay attention to it. So it's not going to be really detailed, just some basics, some good practices. Did I hit something wrong? OK. So first, what file systems do we have on Blue Waters? We have home. It's a shared file system. It's global. You can access it from any node. Pretty small. There are very few resources compared to other file system allocated to it. And it's backed up. So it's the best place to put your code in. You don't want your data, and you don't want to run on that file system if you either read a lot of data or produce a lot of data. Because you would fill it up, and it's not as fast as other file systems that we have. And because it's shared, you will impact other users. So when you log in and you cannot type because the system is slow, there is a chance somebody is trying to do something on home file system. Now, project is a bigger file system. It's allocated per group. It's also shared. It's also backed up. It's a good place to store your files if you have a lot of small files, because the other big file system is better suited to store large files. So you would rather not store your small files on project. And it's a place where multiple users in your group can store files. So it's a good shining point. Now, Scratch is the largest and the highest performance file system that you have. It's ideal to store your large data sets. It's ideal to run. Just for comparison, you have less than 100 OSTs in home, and you have right now over 1,400 OSTs on Scratch, just to get an idea of the difference. You don't want to store small files there because the block is pretty large, and you don't want to store your files there indefinitely because the file system will get purged. I mean, your files after 30 days will be removed. But it's pretty large, and you can either move them to tape or somewhere else. Now, one file system you don't often hear about is temp, and it's pretty small, but it's local. It's not shared between multiple login nodes, and each computer has its own temp. It's ideal to do something quick that requires good speed, and you don't want to be waiting because somebody is running and the file system hangs up. So something like compilation, where you're accessing a lot of files, putting your object files in temp is a really good idea if you have to do a lot of compilation. Now, using Lustre, so just a few general tips how to improve your Lustre performance. Something that if you followed user call, you would see pretty much in every user call, don't store many files into one folder. Any file operation that needs metadata, like opening file, closing file, listing a file, checking file parameters, require multiple accesses to the metadata server. So if you want to LS a folder with 10,000 files, it will put a lot of strain on the metadata server. It's usually not a good idea to have more than 10,000 files because it will impact your performance. And if you have many files and you want to read those files, because obviously you have that many files because you want each rank to have its own file. Otherwise, it doesn't make sense, right? It will lock the directory because any metadata operation is locking the directory. So in order to open 10,000 files, you have to lock 10,000 files, which is obviously not very good performance. So don't go over 10,000. 1,000 or less is better, and it's more than you should really be storing in one directory. If you need to do a lot of I/O, use few files and use parallel I/O. Parallel I/O would be better for this. And if you still cannot utilize few large files, organize your file hierarchically. Have multiple directories, and with each directory having less than 1,000 files, and then you can have as many directories as you want, as long as you put them in hierarchy. Now, if you ever use find on a Lustre, it's recommended to use luster find. This way, it will not, because essentially the standard file, the GNU find will look into each file, and then the request will go to each OST that holds this file. Rather, the luster find will process your request completely inside the metadata server. And especially if there are a lot of files, don't run ls with multiple options, same issue. It will query each of the files from the metadata server. And if you request any options, it will query both metadata server and the OST where the file resides. So if you only do it without options, it will only look into the metadata server. Now, for your large files, you want to stripe them, which means spreading them onto multiple data servers. You can always get your striping with LFS get stripe. It will tell you how many stripes you have and what the size of the stripe is. And LFS set stripe will set your striping. Again, it's size, count. You can stripe both files and directories. If you stripe a directory, that means that each file you will create in the directory will inherit the striping pattern, and you don't have to do it for each file separately. If you move the file from outside into the directory, it will keep its own striping, so you should be conscious of that and restripe if necessary. You would want to pick up the striping parameters that are appropriate for your application and the way you read and write files. It can both decrease and both increase and decrease performance. So don't just stripe to the maximum stripe count, because it will not necessarily make it better. As I said, match it to your application, ideally. And I already said that. OK, so if you want to move data across the system, I would suggest, especially if those are large files. Obviously, if those files are small, you can just copy them. It's OK. If you want to move a lot of large files across the system, you might want to look into using Globus Online, even inside the Blue Waters. And obviously, if you want to move large files outside of the system, then you would better use Globus Online. It will be both much faster and it put less strain on the servers, because if you just want to copy them with SCP, all your data will go through the login nodes. Command line interface is a very useful tool if you have to process a lot of files. You should go and register at Globus Online website to do that. When you are, it's been several issues with that. If you get an ID that is different than your Blue Waters ID, and sometimes you are forced into it because your ID is already taken, you need to take some extra steps. It's documented on the portal, but basically you should be aware of that. When you use command line interface, it's useful to check the status of your transfer with the status command. And when you use it to move data to tape, which is our nearline storage, you shouldn't put a lot of small files on the tape, because it's both not very high performance solution and it's not a good practice. If you have a lot of small files you want to put on tape, you should tar them and only put a few. And don't put directories, because you don't want to go into the directory structure. OK, now something about running your code. And obviously, you want to use a parallel file system to access your data, read and write them in parallel. This first suggestion is not something you will hear often, I guess. But if you have a few ranks, you might save yourself some headache and just actually use separate files per rank. It's OK, but only if you have few ranks to read and write. You should avoid reading shared data at all. Like, if you have 1,000 ranks and you have some shared initialization parameters, you shouldn't be reading them by all. 1,000 ranks, it's better to read by one rank and distribute by broadcast. Or if it's a big chunk of data, you should use some scatter-gather operations. Well, once it's read by a small subset of ranks, or one rank, depends on your application. You want to minimize any kind of file system metadata operations. What this means is you don't want to open and close your files during the application multiple times. If you intend to read from the file occasionally, open it at the start and close it at the end. Don't open, close, because as I said already, all metadata operations will be locked in the directory where the file allocated. And now, this is a different kind of metadata. If you have any sort of metadata in your files, meaning if you store in arrays, dimensions of the arrays, sizes of the arrays, your metadata will depend on your kind of data, but it's better to store them separately rather than interspersed within your data file. This will help with alignment of reads and writes and general performance. Okay, now if you have a high number of ranks, you would probably want to have only a few large files where you would use collective parallel I/O to read and write. You don't want to use all of your ranks to read and write if your number of ranks is really high. Since as the number of ranks increases, even if you want to read from a large file or write to a large file, say you have 8,000 ranks and you want to read a 50 gigabyte file, seems like a big file, right? Well, if you divide 50 gigabytes by 8,000, then the amount of data that each rank is going to be reading is fairly small. You might get away with it when you're reading, but when you're writing and hitting the same OSTs from different processors, it will not improve your performance. Now, this is something, okay, I didn't finish with that. So if you have to run with very high number of ranks and you need to get the data to all of them, it's better to allocate a subset of those ranks that will only deal with I/O and then distribute the data from and to that subset. Next step is something that might not be possible with all applications, but it really helps when you separate your I/O code from your application code. So there is a clear logical separation between them. And it's also useful when your I/O does not depend on how many ranks you're running. It's kind of similar to what I said before, but if you can allocate like 200 ranks for I/O and run with 8,000 ranks, and then without many changes run with 100,000 ranks, but also still use that limited number of I/O nodes, if your application can handle this separation, it's very good. You want to try to align your reads and writes. It's obvious, but pretty often we don't see that happening. You want to aggregate. If you are writing your data, you don't write each point one by one. Even so, there is a buffering both in the I/O libraries and the file system. It's better if you just transfer the whole region into memory, into disk. And you want to tune your I/O to your access pattern. It will depend on your application, and it will help you with that, but it's always helpful to look into tuning. Another thing is to use the work that other people already done. So if you have to do some tricky I/O and you're not sure how exactly you want to handle it, look into the parallel I/O libraries. We have several that are supported on Blue Waters, and here's a link. Again, you need to know how to use them, and we'll help you with that. But it's better than just starting from scratch and trying to write something on your own. And Galen said the first thing you do when you profile is to unload Darshan. It's better that you do not unload Darshan when you do I/O because it keeps profiling for you, and it's very lightweight. And if you have an issue and you come to us and say, well, I have this application and it writes really, really slow, we can either do multiple runs and do the testing, or if you didn't unload Darshan, we can look into what Darshan collected and maybe tell you right off the bat what was your problem or what we think. So if you don't have a good reason to unload Darshan, don't. It doesn't cost you anything, and it's good to be there. Okay, we have a recent change that's related to I/O. The number of OST will be reduced, but the number of disks will grow. So your aggregate bandwidth should be the same. At the same time, you'll have fewer stripe count. Your max stripe count is smaller, but bandwidth of each individual OST that it can provide is higher. So it shouldn't really matter much, but again, your application may be different, and if you encounter issues, we'll be happy to help you with that. And that's it.
Thank you, Andriy. All right, so for the last slide that Andriy showed, we haven't made that change yet. That's with our Scratch file system. And for those of you who are on Blue Waters, you've been getting periodic messages that these things are coming up. So our next maintenance will be doing some work on some of the file systems next week, hopefully getting Scratch ready so we can do an eventual upgrade later in summer for the Scratch file system. All right, so are there any questions for just kind of general best I/O practices? Andriy kind of went over a lot of good ideas, not a lot of examples, but a lot of them are really application specific. Gerd's going to give us a talk on some stuff specific to HDF in a minute, but if there are any general questions. Okay, Scott Noble.
Can you briefly describe when you would need to change the striping for your directories? Like, is there a red flag that
well,
if you're investigating like really long I/O interactions, then you should consider varying that?
Well, the striping for directories really doesn't do anything except it gives the striping pattern to the files that you store there. So basically, it depends on what files you store in the directory. It's not the directory doesn't change in any way. It doesn't affect it. It's not affected by striping in any way because the directory is just a small record of files. You want to stripe the files, but by setting a directory, each file you will create in the directory will inherit that striping. So if you tell me what kind of files you have, then it's really application dependent.
Oh, okay, so I usually run in one directory, and my data is written in that one directory, so I guess all the files would inherit that striping.
Okay.
So, so I guess can you tell me like an example of why I should be concerned with this? I mean,
how many files do you have?
Less than 100.
Then you shouldn't worry really about the number of files in the directory.
Okay, but
and
each file could be striped, right?
Yes, each file will be striped. And
so, okay, so
how big are those files?
Tens of gigabytes.
Okay, then it will help if you stripe them. And how many API ranks read and write from those files at the same time when you do your computation?
So yeah, so it goes through one processor and it writes to one file. So I do a gather over all the processors.
Okay, well, if you only do your reads and writes from single process, it will not help you much with read and write, but it's still a good idea to stripe so you utilize multiple OSTs. So you don't put all your data on the same server.
Okay, so can you abstractly tell me when I should be concerned with this? Am I being too?
Well,
it's a general question. So we get asked all the time, what do you recommend for striping? And it really depends on the application and the I/O characteristics, the access pattern and how many ranks are reading files at one time. So in general, it's good to have, if you have a 10 gigabyte file, it wouldn't hurt to stripe, let's say have a stripe count of 4, stripe it across 4 OSTs. It may not help with the aggregate overall performance when you read the file in. It might help with the write, I mean, it could help, especially because it's a shared resource. So as you're reading along and OSTs are being used by other workloads, then it might help. But it really is unfortunately, it's on a case-by-case basis. Like if you go look at other websites like at NERSC or Nix, you say, well, 4 might be good because it fits well across multiple gigabyte files. But it's difficult to come up with a concrete, solid answer, even though we've had attempts to do that, and there's some general guidelines, but there really isn't a nice formula that you can plug in and come up with a good answer.
Have you ever calculated your I/O bandwidth?
No. Yeah. So we don't see too much time spent on I/O interactions, but so it's not been a big concern for us. But
We can check with Darshan. So if you haven't unloaded Darshan, then we can take a look. So if you want, we can, if you want to open a ticket with us or with Jing, who's your contact for the moment, and we can take a look.
Well, another thing, if you end up on one of the OSTs that is near to getting full and you write a lot of data, if you only have one OST, you have a chance of locking your file up until admin comes and cleans up that OST. If you spread out on multiple OSTs, the chance of that happening is much lower.
Okay. I think one more comment.
Yeah, I just got an additional comment on that. The access pattern matters too, right? So if many nodes are accessing different parts of the file, they could concurrently, then you could potentially end up with reducing contention by striping and having it across multiple OSTs, particularly if they're designed offsets. The other thing I'll point out that might be a gain if you were striping for files you write to is that there is a dirty cache that is per OST on each client. So a certain amount of memory, I think it's with the upgraded file system will be around 128 meg. So depending on the access pattern, if you're writing in amounts that are similar to that where it would be broken up, you might get a better write cache effect by distribution of it.